Sharing. All right. This is where we left off last time in section 2. There's one more thing I want to talk about. Here, I'll give you two graphs. Tell me the domain and range of both of these graphs. This is from section 2. Tell me the domain and range of these graphs. What does domain look at? The x values. So in this first graph, what are all possible x values of my graphs? What's that?
No.
Just no.
It looks like a parabola. So it's like going.
It is, but it's not just infinity. You're right, but you're wrong the way you stated it.
It's like an order pendulum, like negative.
There's just the x values. What x values can I use from where to where? Notice the arrows here. It goes on forever. It keeps on getting bigger. So what x values can I use? Where is this one going?
Negative.
Negative what? It's going to negative, yeah. But what are my x values there? Here are the x values. Here are the x values. So how far can I go left on the x values?
Negative.
Negative infinity. To where? How far right can I go? Yeah, I know what you were trying to say with the infinity, but is this negative infinity and positive? Because parabolas do go on forever on both sides. What's the range of this function? Like this?
No? Or is the other way around?
It always reads the smaller to the larger. The range is not correct. It goes up to here. Nope, because remember, it has to go from smaller to larger. You can use inequalities if you want. So how would you use inequality here? No.
I don't remember. It's been a while.
In this one, what's the lowest you can go? Would you check? What's the highest you can go?
4.
Now, what's wrong with this statement?
Oh.
Parenthesis means you can never get to it.
Bracket.
Bracket means you can get to it and include it. Yeah, we haven't talked about that yet, but I was going to see if you all knew about that. That's one of the things I gave y'all.
Verbally speaking about it, you have to say parentheses, negative infinity for the bracket. Or because you just
Well, it's not, if you did it verbally, then you go from negative infinity, but infinity we can never get to, so we don't have to worry about that. From negative infinity to 4, including 4.
Okay.
Because if you just say to 4, that means just getting very, very close to 4. Like 3.999999999. That's getting to 4. Or you can say that y is less than or equal to 4. But you have to be able to do both ways, which we haven't talked about that yet. That comes at the end of this chapter, and that's why I gave you those sheets there. But until then, we'll try to work it all out. So yeah, the difference between a bracket, which means we can go there and use that number, and parenthesis means we can't. We can never get to it. How about this one? What's my domain in the second question?
No, -4 bracket to 3 parentheses.
Very good. Because a solid dot means you can get to it. So I can get to that one, and the open circle means I cannot use it. So that's perfect. Since you opened the can of worms about inequalities, how would you put that one as an inequality?
Right? No, greater than -4. But the inequality has to have a line under it.
There you go. It's
And
less,
then-
so -4 is less than or equal to X.
And then, has to be less than 3.
Right. Because you always read left to right. So -4 is less than or equal to X, all these, which is less than 3. Again, we'll go over all this stuff at the end of this chapter.
I'm trying to figure out how to-
Or we can do that today if y'all want. Doesn't matter. All right.
Take it back.
How about the range? Is- What's the range?
Why you put it on Zoom?
Because that's where it goes. That's the range is the Y values. So it starts at 2. Can I use 2 or not? Is it a parenthesis or a bracket?
Right.
Parenthesis is open. Then it goes all the way up to 5. Can I use the 5? Yes, because it's a solid dot. Makes sense? So, it doesn't, which is again, I don't like the way they do this in the textbook, because we haven't talked about inequalities or parentheses or brackets yet, and they're throwing it in there in the first 2 sections. They're throwing it in there. But no, we'll talk about that. And again, once we do section 6, it'll make it a lot much easier to understand. Which I'm thinking about just doing today, if doing the library of functions as well as the inequalities, just to get that, because we're going to be using those as we go out through this whole course. So I'm thinking about, instead of doing the next section, section 3, let's just go ahead and do the inequalities and functions, so we know what we're talking about from here on out. Because remember, in your packet I gave you, or I was supposed to give you, use the graphs, tell me domain range. What's the domain of these functions? You don't know because you don't know what these functions look like. Any of this stuff, we don't have any idea what they look like, what we can do with them. So I couldn't tell you what the domain is. Where's my sheet? Oh, well. Let's go ahead and look at the domain of the inequalities as well as can somebody give me a graph sheet, please? From the back, so but you need yours. So we're going to look at the library of functions. Thank you very much. And inequalities. That's what we're going to do today. Because we've already been introduced to it, but we haven't been introduced to it. So let's look at the library of functions. Here's your sheet I gave you. The first function is called a constant function. it looks like f of x equals some number. C is some number, any number you want to give me. Like it could be f of x equals 2. Now, okay, when you get those sheets, okay, those of y'all came in late. You have the oh stop. Before you start grabbing things, stop. You have the graph sheet that looks like this. Only take one. You have this inequality, only take one. But the one that says transformation rules, take 2 sheets. Now, some of y'all may not have done that, which has thrown everybody off. So you need to have 4 sheets in total. You only have one graph, one inequality, but you need 2 transformation sheets. And they have to be different, so make sure they're different. Okay, so a constant function. Let's say f of x equals 2, so it's a number. There's no x's in there. What this graph looks like is it's a horizontal line that goes through that value 2. What's the domain of this function? Negative infinity to positive infinity. Okay, because of the space limitations, here are notations. Instead of writing negative infinity to positive infinity, I could simply refer those to real numbers using that symbol. If you see that symbol, that means it goes from negative infinity to positive infinity. Mathematics is full of symbols like that. What's the range? The range represents what? The y values. Is 0 inside there? Is the y, it's 2. In this case, it's just c. So that's the first function. It's a constant function. The next one we have is called a linear function. And that looks like x. Or just it can have a number in front of it, but it cannot have an exponent. It cannot have a special operation. It can't be on the bottom. It has to just be x. This graph looks like this. Because when x is 1, y is 1. When x is 3, y is 3. When x is -2, y is -2. That's what that one tells us. What's the domain? Yeah, negative infinity to positive infinity, all real numbers. In other words, when you're asked for domain and range, you should ask yourself 3 questions. Can the numbers be negative? Can the numbers be positive? Can it be 0? Like this one here. Can my x's be negative? Yes, there's a graph there. Can they be positive? Yes. Can it be 0? Yes. So it's all real numbers. How about this one? Can they be negative? Can they be positive? Can it be 0? Yes, so it's all real numbers. How about the range? Can it be negative? Yes. Can it be positive? Yes. Can it be 0? So it's also all real numbers. So those are the first 2 equations. The next one we call a quadratic function. That one looks like x squared with a 2 on top of it. x squared. What happens here, whenever you square a number, so can my x's be positive? Can I put positive numbers in there? So 2 squared is 4. Can I put 0 in there? Okay, everybody, put your phones away. I don't want to see, no, not on your desks. Yeah, I don't want to see any phones on tables or in your laps or anything. No. I mean, so if I put positive 2 in there, I square it, I get what? If I put 0 in there, what do I get? If I put negative 2 and I square it, positive 4. Negative 2 times negative 2 is positive 4. So what this graph looks like is that. It's called a parabola. What's the domain? Can the values of x be negative?
Oh,
Yes, which we just said. You put negative 2 in there. Can I put 0 in there? Yes. Can I put positive? So it's all real numbers. Negative infinity, positive infinity. How about my range? The range is the y values, my answers. Can my answers be negative? No. Can it be 0? Can it be positive? Or I could put y is greater than equal to 0. Either one of those. Next one is a cubic function. Cubic means the exponent is a 3. Can the x be positive? Can I put, if I put a 2 in there, can I cube it? 2 times 2 is 8. Can I put 0 in there? 0 cubed is 0. Can I put a negative number in there? Negative 2 times negative 2, yes. So my domain is all real numbers. How about my answers? If I put a positive number and cube it, what do I get? So what's 2 cubed? 8. So it's positive. If I put positive, put positive. If I put 0 in there, is 0. If I put negative 2 times negative 2 times negative 2, negative 8. Because if you negative times negative is a positive times negative is a negative. So in this type, that's a cubic function. So it could be all real numbers. Because if I put a negative 2 in there, negative 2 times negative 2 is positive 4 times negative 2 is negative 8. All right, so let's look at the opposites of those now. Square root function, or I'm going to call these a radical. The square root of x. Can I put a positive number in there, like 4? Square root of 4 is 2. That's okay. Can I put 0 in there? Yeah, 0 times 0 is 0. Can I put a negative in there? No, because the square root of negative 4 is not negative 2, because it has to be the same number. So what we know here, my domain is from 0 to positive infinity only. Can my answers be positive? Can they be zero? Can they be negative? No. So it's the same thing. It's from 0 to infinity. But now, if I use inequalities, my domain, I say x is greater than or equal to 0. And my range is y is greater than equal to 0. Let's look at this one. When x is 0, y is 0. When x is 1, square root of 1 is 1. When x is 4, square root of 4 is 2. And it grows slowly, so it looks like this. So that's a square root. That's the radical. Then we have the cube root, also a radical. Let me explain to you the difference between these two. Why they call it a cube root, why they call it a square root. Let's look at radicals. What do we know about the operation of a square root? Why is the square root of 4? What is the square root of 4? Why is it 2? Why is the square root of 16 4? Anybody know why? Yes. So inside here, 4 is made up of 2 times 2. Since this is a square root, we need 2 of a kind. Once we have 2 of a kind, we take it outside of the radical. So here's this radical, we take it outside. There's nothing left inside there. 16 is made up of 4 times 4. Since there's a pair of them, I take it out. There's nothing left inside the radical. I don't need it anymore. Now, why is it 2 of a kind? Because inside here, there's an invisible 2. Tells us we need, this number here is called a root. It tells us how many of a kind do we need to take it out. Because it's invisible 2, it tells us we need 2 of a kind. So if I gave you the square root of 8, what would that equal? Well, let's break it up. What is 8 made up of? 2 times 4. What is 4 made up of? So 8 is made up of 2 times 2 times 2, right? 2 times 2. And it's a square root. How many of a kind do I need? I need 2 of a kind. So here's 2 of a kind. It goes out in front. Whatever's left stays inside the radical. So there's my answer. Once you break it down, prime factorize it, whatever's left after you take out every 2 of a kind, you're done. That's whatever's left inside there. Cube root. Cube root. It has a 3 there. So it tells me what? I need how many of a kind? So the cube root of 8. Right, 8 we know is 2 times 2 times 2. We need 3 of a kind. We got it. So it equals 2. There's nothing else inside there. Because there's an odd number, I can take the cube root of -8. Because -8 is made up of -2 times -2 times -2. I have 3 of a kind, so my answer is -2. So far, so good? So the cube root of 16 would be what? Or actually, cube root of -16. So I see some of y'all just got glassy eyed. Let's do positive 16. Because inside cube roots, you can have positives or negatives. So 16 is made up of what? 4 times 4. 4 is made up of 2 times 2. 2. So it's made up of 2 times 2 times 2 times 2. We need 3 of a kind. So that'll come out in front. That 2 comes out in front. How many are left inside there? Just that one. So 2 cube root of 2 is the answer. That's how you simplify radicals. So in other words, what you have to do first is take this number, prime factorize it, break it down to its smallest numbers. You can't go any further, and then count how many you have. So let's look what the graph. So the graph of this one, can I put x to be positive? Can x be 0? Can x be negative? Yes. So what this graph looks like is like this. Let's look at the last 4 we did. Here's x squared. The difference between x squared and x cubed is an x cubed, I can have negative numbers. So I'm taking this side and just flipping it over. They both have this part the same pretty much, except now I could put negative numbers. So I'm jumping a whole bunch of steps ahead of y'all. If you notice, the root is odd and the power is odd. If you have an odd exponent or odd root, your answer is going to be positive or negative. If it's even, they can only be positive. If it's even, it can only be positive. Yeah, so if you have an odd exponent, which we call this number here, we call it a degree. If the degree or root are odd, the answer can be positive, negative, or 0. So if the degree or root are odd numbers, for example, if it's a 3, 5, 7, 9, 11, or so on and so forth, then our graphs will be positive, negative, and 0. So if that's the case, our domain and range are all real numbers. Negative infinity, positive infinity. But if the degree or root are even, then your answers can only be positive. And zero, yeah, obviously, yeah. Because zero is a universal number. It fits in everywhere, except on fractions. So if you have an even degree, you can use positive, negative, and zero, but your answers are all positive. If you have an even root, your answers can only be positive. And this is going to help us later on when we start doing transformations and solving these things, no matter how big they are. If I give you an equation that has x to the 15th, what do you know about it? If it's x to the 15th, that means my graph will be mostly on the positive side. All right, let's look at the next half. Oops, should have flipped that over. This side, we do a lot of weird stuff. The next one is irrationally. What does a rational equation look like? Rational simply means fraction. What do we know about fractions? What's the only limitation we have there? Can I have zero on the bottom? So we cannot have a zero number, so we can't use that number. Now, how about as x gets bigger, what happens to the graph? As x gets bigger, what happens to this number? It gets smaller. 1 over 1 is 1. 1 over 2 is 1/2. 1 over 10 is 1/10. 1 over 100 is 100th. So as it goes to the right, it gets closer to zero. But the closer it gets to zero, it goes higher and higher and higher. Right. Zero is an asymptote there, vertical asymptote. So on the positive side, if x is positive, the answer is positive. If x is negative, then the answer is negative. So the farther x goes towards infinity, the smaller this number becomes. So if it's, let's say at 1/2, if x is 1/2, what is my value of this? If x is 1/2, yeah. If I had 1 over 1/2, take the top, leave it alone, and flip the bottom, it would equal 2. So whenever you have a fraction on the bottom, flip it. If I had 1 over 1,000 on the bottom, it would equal 1,000. Because my denominator is a fraction. If it's a fraction, then I flip it. So what's my domain? X cannot equal 0. It could be anything else. It's just that x cannot equal 0. Likewise, the range, y cannot equal 0. Because the only way a fraction can equal 0 is if the top is 0. All right, so that's a rational expression or equation. How about a rational squared equation? 1 over x squared. So what's going to happen to our graph? What do you mean flip?
Maybe you'll know, like, this side is gonna go.
Just that side, yes. Yep. Can your answers, can x be positive? Can x be 0? No, you cannot divide by 0.
Oh, yeah.
Can x be negative? Yeah, it can. If I take a negative 4 and square it, I get 16. It's just 0, I can't. So in other words, no matter what I put in there, if I put a negative number in there, it comes out positive. If I put a positive number, it comes out positive. So it looks like the Atari symbol. So my domain is what? Can I put positives in there? Can I put negatives in there? Can I put 0? No. So my domain is x cannot equal 0. How about my range? The y values, can the y values equal negative? No, nothing down there. Can it equal 0? No, there's no intercept. Can it be positive? Yes. So my range is y is strictly greater than 0. So far, so good. How about the absolute value equation? What do we know about absolute values? Besides what they look like. It can never equal a negative. Can I put positive in there? Can I put 0 in there? Yeah, absolute value of 0 is 0. How about negative? Can I put a negative number in there? Yeah, it becomes positive. So because it's x, my graph looks like this. So my domain are all real numbers. What's my range? Why is my domain all real numbers? Remember, 3 questions. Is my x, can I be positive? Can it be negative? Can it be 0? All real numbers. My range. Can my answers be negative? No. Can it be 0? Can it be positive? So yeah, so we're looking at 0 to infinity, or y is greater than equal to 0. What is it? I want to call it a cardinality. Call the greatest integer function. What this function deals with is only to what number is on the left side of the decimal. Anything to the right side, you just get rid of it. That's what this one does. So Here's what I mean. So at 0, I get 0. At 0, if I had 0.1, what's my answer? Get rid of the decimal, it's 0. At 0.5, what's my answer? At 0.9, it's 0. How about at 1.0? So at 1, it jumps up here. So this one becomes an open circle. So it goes from 1 all the way up to 2, then it jumps up there. It's called a stair-step function. On the bottom here, it does the same thing. So it gets rid of the decimals and just takes what's in front of it. So, oop. And it goes on forever and ever and ever. So what's my domain? Yep. Oh, good job. All real numbers. Because my numbers could be positive, negative, and 0. What's my range? Nope. It can't be all real numbers because I don't have any decimals. This is only the integers. Only the integers are numbers. 1, 2, 3, 4, negative 1, 2, 3, 4, including 0. There's a couple of more I'm missing. Well, I'll come back to those later on. But these are the basic functions we're dealing with so far. We'll finish up these last two another time. But I'll get to the inequalities first. Let's space out what they were. Inequalities. What are inequalities? Inequalities when we have those pointy arrows. Remember, you always read left to right. And the arrow points to the smaller number. So what would that represent? What does that mean? How would you read that? X is less than 3. How about this one? X is less than or equal to 3. What's the difference between those two? If we were going to look at these as a graph, here's 3. X is less than 3. Can we use 3? No. So it's an open circle at 3. We can't use it. We get infinitely close to it, but we can't use it. And X is less than. So it means it goes everywhere to the left. How about this one? Can we use 3? Yes. So it's a solid dot. X is less than, so it's to the left. That's the graph. That one, X is greater than 3. You probably heard made phrase like this: an alligator goes for the bigger piece of meat, the lion goes for the bigger piece of meat, as opposed to this one. X is greater than or equal to 3. So the graphs of these, here's my number 3. Here's my number 3. Since I can't use 3, this one has to be an open circle. Why can I not use 3? Because it just doesn't tell me it's equal. There's no equal sign in there. X is greater, so X has to be that direction. X is greater than or equal to 3, so it's a solid dot there. X is greater, greater means goes to the right. So it goes that way. If your X's are on the left-hand side, once you plot the number, this arrow tells you what direction you're going to shade. If your X is on the left-hand side, it says shade to the left. Go to the left. Shade to the left. Shade to the right. Shade to the right. Do you always have to have X on the left? No. How would you graph that one? How would you read this one? Four is less than X. You read left or right. 4, this symbol's less than, 4 is less than X. So here's 4. Is it an open or a closed circle? It's open. What side gets shaded? To the right. Because remember, what's shaded is your X. X has to be less than that. Less than means smaller, means to the left. If you don't like the way this looks, you can always flip it. Just take it and flip it over. So X, these now mean the same thing. You can rearrange them as you want to, but if I move the X to the other side, then I have to flip the direction of the arrow. Because what this thing says is X is greater than 4. X is greater than 4. That's what it means. Make sense? Now, we have 3 types of numbers that we deal with. We have set notation. Set notations are these part, like X is greater than 4, or 3 is less than equal to X is less than 5. That's set. Whenever you have the inequalities, that's called a set notation. The next type is called interval notation. Interval notations, these are inequalities. Interval notations deal with parentheses and brackets. Like that. The last one is graphical, the graphical notations. Here's where you use open or closed circles. And you shade the region. Whatever shaded, that represents where your X values are. All right, let's do this table. We have 4 different types of categories of inequalities that we deal with. Infinite and closed. What if we had that? This is my graph. It's always easier to translate from graphics. How do we put that in set notation? So remember, the shaded region represents what? X. What this thing tells us, since X is to the right of A, it tells us that X is greater than A. Can I include A? Yes, because it's a solid dot, it's greater than or equal to A. Now, the interval notation, all you do here, you find where it begins and where it ends. At both ends, on the left-hand side, it's negative infinity. At the right-hand side, it's positive. So this goes from where? It goes from A to infinity. So it goes from A to infinity. Can you ever get to infinity? No. Infinity is always going to be a parenthesis. Can we use A? Yes. So we use a bracket. Now we have this one. The shaded region is to the left of A. That's, remember, these are my X's. So my set notation, since x is, if it's to the left, if a number's to the left, is it less than or greater than? Less than, because the smaller numbers go to the left, bigger numbers go to the right. So x, since it's to the left, is less than a. Since a is a solid dot, it's less than or equal to. That's the set notation. Interval notation, again, where is the farthest left I can go? Negative infinity, very good. And it goes all the way to a. Infinities are always parentheses. That's solid, so it's a bracket. The next set are infinity and open, so I'm going this way. Okay, these are my x's. My x, since it's to the right of a, that means it's greater than a. And also, remember, it's shaded going to the right, so I'm pointing to the right. Can I include a? No, it's open. Now for the interval, what's my smallest, what's my largest numbers? Here's my interval. I go from a to infinity. Infinities. I cannot use a, so it's also a parenthesis. Because it's open. I cannot use it. And here's my, these are my x's. Since x is to the left of a, that means x is less than a. Also, because it's shaded, it's pointing to the left. I can't use a, so that's it. What's the smallest? What's the largest? The smallest is negative infinity. And it goes all the way to a. And I can't get to both of those. So those are my four infinity, where it starts at a number and goes to infinity, either positive or negative infinity. Now, the next two, I'm going to go between numbers. They're finite, they don't go forever. Remember, these are my x's. So where is x in this one? It's in the middle. So we have a. A is, since it's to the left, a is less than x. Since it's solid, I can include it. But x is to the left of b, so it's less than or equal to b. Because x has to be between a and b. My interval notation, the smallest I can get to is a, the biggest I can get to is b, and they're both solid, so they're both brackets. X has to be between there. And here's my, I shaded between there. So again, X is between A and B. X is bigger than A, but less than B. I can include A, so I put a line underneath that one. There I have it. A is less than X is less than B. The smallest I can get to is A, and the biggest I can get to is B. I can use A, I can't use B. X is between A and B. So since X is between A and B, A is less than X, and X is less than B. But I can include B. Since it's solid, I can make it equal to. So my range goes from A to B. I can't use A, but I can use B. I cannot include A, I can include B. And the last one of this set, again, A is less than X, because it's to the left, and X is less than B. And I can't use either of them. So my range goes from A to B, and they're both parentheses. Now we're going to opposite directions. I'm going to look at this part. Now I have two sets of information. I have this first one, X is less than A, or less than equal to A, or X is greater than or equal to B, because it's to the right. It's or. My answer can be either here or it could be here. Either way, I win. Now it comes a little different when we do this interval notation. Remember, interval notation, you have to have a beginning and an end. So we have negative infinity goes to A, bracket. That's this first one. And then we go from B to infinity. So B to infinity. B is a bracket. The symbol we use for interval for or is the union symbol. The union symbol means or. My answer is either going to be in this group or it's going to be in this group. So these are my X's. Again, X is less than equal to A, or X is strictly greater than B. So I'm going from negative infinity to A, it's a bracket. Then I'm going parenthesis B to positive infinity. And I have a union there between them. Because it means or. So in this next one, X is to the left, so X is less than A, and I cannot use A, so it's a strictly less than, or X is bigger than B, and I can use it. So I'm going from negative infinity to A, parenthesis, union, that's a solid, so it's a bracket, B to positive infinity. Remember, the intervals, I have to start and end in that interval. We're almost done. So we have X is less than A, or X is greater than B, and I cannot equal them. Negative infinity to A, union B to positive infinity. You notice how this start the lowest and the highest of that interval. The lowest and the highest. How would I represent the point? X equals A. What that also means, since I can include it, it's that point. Now what this one says is I can't use that, so I can use everything else. How would I represent that?
Not known.
Very good. X does not equal to A. How about the interval? If I use a parenthesis, I can't use that number. So what this says is X can be anything but A. How about this one? From negative infinity to positive infinity. What this one says is I go from negative infinity to positive infinity. What's another way of writing that? All round numbers. Which means I go from negative infinity to positive infinity. So those are the inequalities. We're going to be seeing those a lot in these courses, as well as all these functions. So when you see an equation that has a square root, you know what the graph's going to look like. You know now that the inside cannot equal negative. The smallest it can equal is 0. So now from there, we can start working on it. All right. We haven't next time we're going to do sections 2 and 3. And we're going to finish up the chapter next week for sure. We've already done part of section 6, so that's not going to worry about us too much. We just now have to continue the process of slopes and lines. Not just yet, because we haven't learned how to solve equations with inequalities. We'll do that in section 6. Yeah, just still section 2. And next week, we're going to finish up everything else. So we're taking our time. I'd rather start the semester off very slow and get the rules down and start picking them up, because we're going to need to know all this stuff when we do chapter 4. Chapter 4 is the most difficult chapter of the whole book.